Okay, thank you, well done, for inviting me here today in order to proceed with our lesson of mathematics, particularly in the topic which you call it calculus. But before proceeding, let me provide thanks to God who provided energy for me to exist here in order to provide or in order to exhaust what I have to my learners. Well, thank you, my learners from Uganda. Thank you, my learners from Tanzania. Thank you, my learners from Kenya. Thank you, my learners around the world who follow my lessons. But also thank you, my learners, for participating in the face-to-face lessons in my classroom. But in this lesson, we are going to concentrate on the meaning of the calculus, not only meaning of calculus, who discovered calculus, or scientists who discovered calculus, but also the importance of calculus. And later on, we will proceed with another lesson, which will proceed with another things, which is very, very important for us. So let us concentrate on what is the meaning of calculus, or the meaning or the concept. Let us proceed with the let us dig in the concept of the calculus. Calculus is the study of how things changes. That's how a system changes or how things changes, that we call it calculus. So calculus also meaning that calculus is the study of how things changes. But after knowing the concept of calculus, we are supposed to know the inventors of calculus. We can't talk about the calculus without remembering the other scientists or tracing back the history of scientists who discovered the calculus. One among the scientists which discovered the calculus is one among the famous scientists which call it Isaac Newton, in which he was the famous in the Newtonian mechanics. So Isaac Newton is one among the scientists or mathematicians in which inventing the calculus, particularly by using the function y is equal to fx. So he was developed y is equal to f of x in terms of differentiation, particularly in the part which he was trying to introduce the f dash of x to differentiate the parts of calculus. But also we have Gottfried Leibniz, in which is another scientist which introduced the dy over dx, which introduced the function that is equal to dy over dx as the function, while as Newton introducing f dash of x. So when Leibniz introduced introducing how to deal with the function in terms of dy over dx is equal to function, Isaac Newton was introducing the function as f dash of x. So that is the scientist or mathematician which is very famous when he was trying to introduce the concept of the calculus. But another very important issue to note is that differentiation is the advancing subtraction, while integration is the advanced addition or sum. That's why even the symbols of difference. That's why even the symbols of integration is they come from the symbols s, in which s is stretched to produce this snake-like structure in which tell us about the integrations. Mean that integrations is the part of calculus, as well as differentiation is the part of calculus. So calculus including the integration and the differentiation. So integration, differentiation is the part of calculus. So advanced subtraction we call it differentiation, while advanced summations or addition we call it integration. And integration introduced by letter which seem like the snake-like structures. Means that it derived from the term from the word summations to produce the snake-like structure, which tell us about the integration. So let us proceed with other parts which we call it the importance of calculus. Let us see why calculus is very important for us. That's why people are interested to learn calculus every day. Calculus is very important for us due to the fact that, number one, calculus gives us the framework of modern system. not only but also calculus give us the way to deduce the prediction of the model. Not only but also calculus help us particularly in the professional people such as scientific careers, but not only but engineering. It means that calculus help us to get engineers as well as scientific. It means that on the other hand we can say that calculus is very important for scientific careers, not only but also it's very important is in engineering. For example, let us see here to learn how things changes, which is calculus. Let us see here how a final changing or cause the dynamics in the system. So when a final is in this position, it's laid as a positive, but when it's changing the system, it can change from here, which is more negative. So here it shows that there is a changes which occur, but the change which occur here is due to the bond formation and the bond breaking. So when they are in the system, can change their positions, but this position which they are changing we call it dynamics. This is very important used in by the drug designers, by using also when they are tending to use the concept of the Licataris principle hand loss Licataris. When the people that tend to use the concept of the having loss Licataris about the dynamics or changing of the system. For example, the drug designers are most interested in the changing of the system, how cell and the drug which made how it interact. So for example here this is a protein. So when protein interact with the ligand, means that your cells protein when interact with the ligand or drug which made cell, when cell interact with the drug which made tend to form drug cell interaction or tend to form the protein ligand interaction. Ligand here we talk about the drug candidate which made. So at this point we are seeing that system change from this position to this position, then again change this position to this position. When when changing to that position means that there is changing in energy or change in heat which can occur. So when the drug designer needed to evaluate the system how it changed, means that protein needed to interact with the drug which a person means that the protein can interact with the ligand or drugs. After interacting with the drugs, there is equilibrium which can be made between protein as well as the drugs, which we call it protein drug interactions or protein ligand interactions. So after doing that, means that there is energy will change when protein ligands made the interaction. After forming this interaction, means that here we need to treat or to inhibit a certain disease. When we need to inhibit a certain disease by using this, later on this drugs which is required to be excreted out by using metabolic process, in which when if it is required to be removed outside, it needed to change again from the protein ligand interaction to the protein and the ligand at separate things, in order to reduce something just like a toxicity in the body. So the drug is required after doing the specific issues which is required to do in the body or to treat or to inhibit a certain disease. Later on that drug is required to be removed. So the drug designer, they are required to evaluate the system to see how system changes in order to make sure that the drug which he or she made is very important for human being or other organism, but to ensure that the drug which made it do not cause the toxicity or do not cause the death in human being. So the drug designer, which is the part of scientific career and engineering, as well as that we call it biotechnologist engineering, they are interested in calculus, which is very important for which is very important to discover things, not only but also to evaluate the system which made, because it protein and the drug, that is just like a system which is required to interact together in order to inhibit a certain disease. After inhibiting a certain disease, it is required to be excreted out of the body in order to reduce the toxic material in the body which can harm harm the body and ultimately and definitely or ultimately can lead to the death of organism. So up here, let me say thank you. Up here, let us see the basic function or the basic derivatives of calculus, because today we are going to concentrate much on the differentiation rather than in the integration. So today our objective, we are much concentrating on the differentiation. So let us see the basic functions or derivatives in terms of differentiation. So let us see how it is. Basic derivative function, basic or derivative. Basic or derivative of functions. When I talk about the basic or derivative of functions here, we are talking about when we differentiate x power n. When we differentiate x power n, when you differentiate x power n, we are going to get n x power n minus 1. We are going to get n x n minus 1. This is the first principle of differentiation. Not only that, but also when we differentiate ln, we are going to get ln. So when we differentiate ln x, we are going to get ln x. But also when we differentiate ln x, we are going to get 1 over x. But not only, but also when we differentiate sin x, we are going to get cos x. Not only, but also when we differentiate cos x, we are going to get negative sin x. We are going to get negative sin x. So, but also there is other derivatives, which is tan. When you differentiate tan x, you are going to get when you differentiate tan x, you are going to get sec square x. You are going to get sec square x. You are going to get sec square x. But when you differentiate the constant number, we are going to end up with 0. So when you differentiate k or constant number, when you differentiate constant number, you are going to get 0. So this is the basic function or basic derivatives of the calculus, particularly in the differentiation. So when you differentiate x power n, you are going to get n x power n minus 1. That's why here we are saying that differentiation in the advanced subtractions. But when you differentiate ln, you are going to get ln x. When you differentiate ln x, you are going to get ln x. But also when you differentiate ln, we are going to get 1 over x. Ln x, we are going to get 1 over x. When you differentiate sin x, you are going to get cos x. When you differentiate cos x, you are going to get negative sin x. But when you differentiate tan x, you are going to get sec square x. To all of that, also when you differentiate constant number, you are going to get 0. You are going to get 0. So let us proceed with the example on how to deal with that differentiation by using the first principle of differentiation. Example, let us see how it is. Differentiate x power 2 with respect to differentiate y. Example number 1. Differentiate y is equal to x power 2 with respect to x. So let us see how it is. Differentiate x power 2 differentiate y is equal to x power 2 with respect to x. So let us dig in to see how it is. The first things to know here is to ensure that we are create the function. So when this x power 2 means that y is equal to x power 2. But remember that this we need to differentiate, so dy over dx is equal to dx power 2 over dx brackets. We need to differentiate like that. So let us proceed. So dy over dx is equal to 2 times x power 2 minus 1. So when you consider this, by considering this, you see that dy over dx is equal to 2x power 1. Means that 2 minus 1 is equal to 1. So dy over dx is equal to 2x. This the derivative of the differentiation of x, the differentiation of y is equal to x power 2. That's example number 1. Let us see example number 2 in order to see how it is. Let us see the example number 2. Let us see the example number 2. Example number 2. Example number 2 tells us differentiate f of x is equal to 10. Differentiate fx is equal to 10x power 3 with respect to x, with respect to x. So here we can remember that fx is equal to f dash x is equal to dy over dx. We are supposed to recall that. After recalling that, you can use here you can use dy over dx is equal to d over dx bracket. You have 10x power 3. 10x power 3. So after here, we are proceeding dy over dx is equal to 3 times 10x power 3 minus 1. Here we are proceeding with that process. So dy over dx is equal to 30x power 2. 3 minus 1 is equal to 2. So dy over dx is equal to 30x power 2. This is so the derivative or differentiation of dy of f of x or y is equal to 10x power 3 is equal to 30x power 2. Let us proceed in the example number 3. Example number 3. Example number 3. Differentiate y is equal to 2x power 2 plus 3 with respect to x. We are supposed to know that what is our function. So our function here, that Our function here is that y is equal to 2x power 2 plus 3. This is our function. This is our function. After knowing this is our function, we are proceeding as normal that dy over dx is equal to d over dx bracket 2x power 2 plus d over dx bracket 3. But remember that when we differentiate, constant number is equal to 0. So here it will become dy over dx is equal to d over dx 2 times 2x power 2 minus 1 plus 0, which is equal to when you differentiate constant number you end up with 0. So dy over dx is equal to 4x power 2 minus 1. So dy over dx is equal to 4x power 1, which 4x power 1 is equal to 4x. So dy over dx is equal to 4x. This is the derivatives of differentiating 2x power 2 plus 3 as our function. So this is the result of what we require to do. Up here, let us proceed with the example number 4. Example number 4. Find the derivative. Example number 4. Find the derivative of y is equal to 6 over x power 4. Let us see solutions. dy over dx is equal so dy over dx is equal to nx power n minus 1, but y is equal to 6x power 4 negative 4. That is how it is. So up here, let us deal with it. So dy over dx is equal to d over dx bracket 6x power negative 4. So let us differentiate it to see how it is. So dy over dx is equal to negative 4 times 6x power x negative 4 minus 1. With that, let us see. So dy over dx is equal to multiply here is equal to negative 24 x power negative 5. So the answer can be like that one. So dy over dx can be 24x power that. So dy over dx is equal to negative 24x power negative 5, or dy over dx is equal to negative 24 over x power 5. So the answer can be like that one. So dy over dx can be equal to negative 24 x power negative 5, or dy over dx is equal to negative 24 over x power 5. That is how it is. So let us see the example number 5. Let us see the example number 5. Example number 5. Let us see how it is. This example number 5. Let us see example number 5. Example derivative of y is equal x power 2 plus 7x minus 6 over 7. So let us see how it is. Record dy over record that record dy over dx is equal to nx power n minus 1, which is equal to f power f dash of x. So let us see how it is. So dy over dx is equal to d over dx bracket x power 2 plus d over dx 7x minus d over dx bracket 6 over 7. Let us deal with it to see how it is. So e is equal to 2 times x, 2 times x power 2 minus 1 plus 1 times 7x power 1 minus 1 minus 0, which when you differentiate the constant number you will end up with 0. So here we end up with 2x, which is equal to dy over dx, or dy over dx is equal to that one. So dy is equal to so dy over dx here, 2 times x become x power 1 plus become x power 0 minus 0, which is 0 is neglected. So dy over dx is equal to 2x plus any number plus 0 is equal to 1, so 7 times 1. So dy over dx is equal to 2x plus 7. That's the derivative of differentiating this number, which is equal to y, and which is equal to y equal to x power 2 plus 7 x minus 6 over 7. That is the example number 5. Let us proceed with example number 6 to see how it is. Find example number 6. Find the gradients. Find the gradient or slope of curve in which that curve, the equation of the curve is that y is equal to x power 3 minus 2x power 2 plus 1 plus x minus 1 at the points at the point 0, negative 1. So let's just see. So the gradient of y is, so what you require to know that so find the gradient of curve y is equal to x power 3 minus 2x or 2 plus 1 minus 1 at a point 0, 1. Mean that the gradient of y is equal to x power 3 minus 2x power 2 plus x minus 1 is obtained by substituting the coordinates point of requested points. So the points of the requested points. So recall, so the gradients, the gradient of y is equal to x power 3 minus 2x power 2 plus x minus 1 is obtained by substituting, is obtained by substituting the coordinate point requested. So we are supposed to know that y is equal to x power 3 minus 2x power 2 plus x minus 1. This is our function. This is our function. dy over dx is equal to f dash of x from the function x power 3 minus 2x power 2 plus x minus 1 is equal to y. Minus 1 is equal to y. So it can be obtained from this function. So the differentiation is done as normal. Then we will substitute at the point. So let us proceed. So dy over dx is equal to d over dx bracket x power 3 minus dy over dx, in which here we are removing this bracket 2x power 2 plus d over dx bracket x minus d over dx 1. But remember that when you differentiate the constant number, you will end up with 0. You end up with 0. So dy over dx is equal to 3 times x power 3 minus 1 minus 2 times 2x power 2 minus 1 plus 1 times x power 1 minus 1 minus 0. That's how it is. So here dy over dx is equal to 3x power 2 minus 4x power 1 plus x power 0, in which if x is equal to if it's x power 0, mean that x power 0 is equal to 1. Any number power 0 is equal to 1. So dy over dx is equal to 3x power 2 minus 4 plus 1. So our equation will become like that, plus 1. So it will be dy over dx is equal to 3x power 2 minus 4x plus 1 times 1, which is equal to plus 1. So at point 0, 1, let us substitute this equation into the point 0, 1. Here it is 4x. So let us see here. So dy over dx is equal to 3x power 2 minus 4x plus 1. When point this mean that when point like this one mean that this is x and this is y. This is x and that is y. If it's x and y, mean that the points of y is equal, the point of y is equal to 1 and the point of x is equal to 0. So x here is equal to the value of x is equal to 0. If the value of x is equal to 0, let us see here how we can do. We can do until be very simple. So let us see here how it is. So here we are at point 0, 1, mean that y is equal, mean that x is equal to 0, y is equal to 1. If it's that, let us turn into a equation that dy over dx is equal to 3x power 2 minus 4x plus 1. Let us substitute this value to this one. Our value here which we're dealing with concentrated heat, it is X value. So let us substitute here to find out the gradient. So dy over dx is equal to 3 times x, which is equal to 0 power 2 minus 4 times 0 plus 1. So dy over dx is equal to 0 minus 0 plus 1. So dy over dx is equal to 1. So dy over dx is equal to 1. Of the curve in which you can obtain is 1. This is the gradient of the curve in which you can obtain after by using the calculus. So mean that another example, another important to the calculus, particularly the differentiation, we can obtain the gradient, or yes, we can. So another importance of the calculus, particularly the differentiation, we can obtain the gradient of the curve. So up to here, let me say thank you, my learners from Uganda, thank you, my learners from Kenya, thank you, my learners from Tanzania, and thank you, my learners who are around the world who follow my lesson. So up to here, let me say thank you, bye bye. Let me say thank you, my learners from Uganda, thank you, my learners from Tanzania, thank you, my learners from Kenya, as well as thank you, my learners around the world who follow my lessons, particularly in this lesson. Don't plan to miss the next lesson. We are going to prepare good things for you. Up to you, let me say bye bye. Enjoy mathematics. Okay, thank you. Well done for inviting me here in order to proceed with this lesson of mathematics, but particularly in the part which you call it calculus. But before proceeding, let me provide thanks to God who give me energy. But before proceeding, let me provide thanks to God who provide energy for me to exist here in order to exhaust what I have to my learners. But also welcome my learners from Uganda, welcome my learners from Tanzania, welcome my learners from Kenya, welcome my learners around the world who follow my lessons. Not only but also welcome my learners who participate in this lesson by individual but also welcome my learners who participate in this lesson in terms of live participations, but also those welcome my learners those who participating in terms of virtual around the world. So for today we are going to concentrate about the calculus but particularly in the differentiation in the part which you call the successive differentiation. In the successive differentiation, we are going to talk about something which can be differentiated more than once, or something which differentiated is successive. So, in terms of successive differentiation, if a function successive differentiation, when we talk about successive differentiation, we are talking about the differentiate function in a successful way, or more than once. So, a function can be differentiated more than once. If a function y or f of x is differentiated more than once, we are getting first derivatives, and that first derivative is denoted as dy over dx, or f dash of x. That is how we can denote that is how we can denote the derivatives after differentiation once, or after doing the successive differentiations. But if that result which we have been obtained, or that first derivatives differentiated again, mean that we are going to get the second derivative, and that second derivative is denoted as d2y, or d, and this is denoted as d2y over dx power 2, or f double dash of x. So this read as d2 by dx square in terms of f of x. This can read as f double dash x. So read as f double dash x. So d2y over dx power 2, that is the second derivatives, or which also can be indicated as f double dash of x. So it can be denoted like that one. But if also, let us proceed to see how it is. Therefore, function can be differentiating in n number times. It can be differentiated in any number, numbers of times, number of times. Which this number of times, this implies that, or tell us that if it is in n, if it is n times, if it is in n times, the differential coefficient is the differential coefficient is given by dfy over dx power n, or can be written f n of x, that fn of x. This can be denoted by this one. That term can be differentiated like this one. If it's d power 3, it can be written d3y over dx power 3, or f triple dash of x. Also can be written, if it's then we can differentiate successive times until to get the nth terms of that differentiation. That is how it is. So up here, let us see an example on how to deal with this successive differentiation. So example number one, let us see example number one here. Example number one. Example number one, let us see how to deal with it. This example number one. After getting this example number one here, let us see. Given that, the question tells us, given that fx, given that fx is equal to x power 5 minus x power 4 minus 5, and we are required to determine f of x. We are required to determine f double dash of x. So here we have the task to do these things in order for everyone to understand what we are talking about. So keep in touch with me in order to understand what you are required to understand very easily, in which this will be very helpful for you to deal with calculus, particularly in the successive calculus. So let us see how it is. So here we are supposed to know that y is equal to dy over dx. But apart from this dy over dx, this implies that also f of x is equal to dy over dx, meaning that this y can be f of x. But here we need to deal with the f of x, f double dash x. So f double dash of x is equal to dy over dx. If it's dy over dx, here we are supposed to deal with it. We are supposed to know that we are supposed to write d bracket d over dx bracket. Here we need to differentiate this f of x is equal to 5 x power 5 minus x power 4 minus 5. So here we differentiate by providing x power 5 minus d over dx, in which we suppose with x power 4, but also minus d over dx bracket 5. But remember that when you differentiate a constant number, you will end up with 0. So here it will become 0. So let us this will become 0. So here dy over dx will become a 5 times x power 5 minus 4 times x power 4 minus 1 minus 0, because when you differentiate the constant number, you will end up with 0. So let us see here. This will become here is 5 minus 1. So here will become 5x power 4 minus 4x power 3. This will become an example on how to do. So this is what we have been getting here. This is not this is f of x, f dash 1x. So we are supposed to deal until to get the f and the f of x double dash. The f of x double dash will be getting like this one. So here it will become 5. It will become dy, not dy, it here become d over dx bracket 5x power 4 bracket dy of d here minus d over dx bracket 4x power 3. We need to find out the dy over dx in terms of double dash or second derivative. So when what you have been getting in the first derivatives, so this is the first derivative, so we need to find out the second derivative. How we can get second derivatives? Let us dig in. So we are taking the product of the first derivatives, in which is this one, to find out the second derivative. So dy over dx here to find the second derivative, which is equal to f double dash x is equal here to 4 times 5x power 4 minus 1 minus 3 times 4x power 3 minus 1. So f double dash of x here is equal to 4 times 5 is equal to 20. So it becomes 20 x power 4 minus 1 is equal to 3 minus 3 times 2 3 times 4 is equal to 12. So here it becomes 12 times x power 3 minus 1, which is equal to 2. So f double dash x is equal to 20 x power 3 minus 12 x power 2, and this is the second derivative. This is the second derivative or d or fx or f double dash x, in which also can be denoted as a d2y over x power 2. So this is how to deal with that, with the first derivatives, the first derivative to get the second derivative. So the f double dash of this is the 20x power 3 minus 20x power 2. Let us see the second example on how to deal with it. So let us see, please. So let us see how to deal with the second example in order to see how it's very simple on how to deal with it. So let us see example number 2. Example number 2. If y is equal to 3x power 5 plus x power 3 x power 3 minus x plus 3. Determine d3y over dx power 3. So we are supposed to find out about this one. So let us see how it is. So here we are supposed to find out the first derivatives. After getting first derivatives, we are supposed to find out the second derivative. After getting the product of second derivative will be help for us to find out the third derivatives. So let us begin to see how it is. So here we start with the first derivatives. We'll find f double dash 1, which is equal to dy over dx as known. If it's dy over dx as known, let us see. So f double dash is equal to d over dx bracket 3x power 5 minus d over dx bracket x power 3 minus d over dx bracket x plus d over dx bracket 3. But remember that when you differentiate a constant number, you will wind up with the 0. Here will become 5 times 3 x power 5 minus 1 plus 3 times x power 3 minus 1 minus 1 times x power 1 minus 1 plus 0. Due to the fact that when you differentiate the constant number, you'll wind up with 0. So here we have 15x power 4 plus 3x power 2 minus x, 1 times x is equal to x power 0. So let us see how it is. So we have 15x power 4 plus 3x power 2, but any number power 0 is equal to 1, so it become 1. So this is the product of this we call it first derivative. So this is the first derivative. So after getting these first derivatives, let us find out the second derivatives in order to get the third derivatives. So here we deal with the second derivatives, which is equal to d over dx bracket 15x power 4 minus 3x power 2 minus 1. We need to differentiate this one. So in order to differentiate this, which is the first derivatives, let us dive in. So f double dash over x is equal to d over dx 15 times 15x power 4 minus this is plus not minus plus d over dx bracket 3x power 2 minus d over dx bracket 1. But remember that when you differentiate the constant number, you went up to 0. So let us begin. So f double dash x is equal to the 4 times 15, 4 times 15 x power 4 minus 1 plus 2 times 3 x power 2 minus 1, 2 minus 1, but also minus 0. So f double dash x is equal to 15 times 4, 20, it is 20, so it becomes 60x power 3 plus it becomes 60x power 1. So f double dash x is equal to 60x power 3 plus 60x. This we call it the second derivative. This we call it the second derivative. Derivatives. Yes, you call it the second derivatives, in which, according to what we are required to write here, this is the this we call it d2y x power 2. So d2x power 2, here we need to find out the d. Here we need to find the f triple dash of x, in which this is equal to d3y over dx power 3. This we need to find out, which we are required to find out. But d3y over dx power 3 is equal to d over dx here, in which we have 60 here. 60 x power 3, not only 60x power 3 plus d over dx bracket 16x. Let us see how it is. So here we are finding out the 30 derivatives of d3y. To find out this d3y over dx power 3 is equal to 3 times 60x power 3 minus 1 plus 1 times 60x power 1 minus 1. So d3y over dx power 3 is equal to 60 times 3 is equal to 180 x power 2 plus 60 x power 0, in which x power, if it is x power 0, so d3y over dx power 3 is equal, remember that any number power 0 is equal to 1, so it will remain 3, 180x power 2 plus 6 times 1 is equal to 6 plus 6. So this is the third derivatives of this number, of this function. So this function, the third derivatives is 180x power 2 plus 6. And how that is how to deal with the successive differentiations. So after seeing how to differentiate the successive differentiation, so up to here, let me provide thanks my learners from Uganda, my learners from Kenya, my learners from Tanzania, my learners around the world, and those my learners who participating in the live participation of these sessions. I would like to invite you to the next lesson. So don't plan to miss the next lesson, because we have a good news in which we are going to prepare for you. So you are one welcome to participate in this lesson. Up to here, let me say thank you. Bye bye. Enjoy mathematics.